So now we are going to move on from the if statement in C to the next, the first of the iteration constructs, right, which is the while loop, right. We already saw an example of while in the previous case where we basically had a while one kind of a condition, right, where we were looping through the different kinds of fruits, going on asking for an input and incrementing the number of various kinds of fruits. I am going to rewrite the same thing, but in a slightly more sort of meaningful manner without suddenly breaking out of the function in the middle using return, by actually making use of the functionality of while, right. And as you can see over here, the initial parts of the code look the same, except that in this case I have actually made sure that I define and initialize my variables. After that, what I do is I actually go in and say, okay, print enter a fruit code. I read in a fruit code, and then I put in a check which basically says if the fruit was not equal to q, then that is, or rather while the fruit code was not equal to q, check if it is a valid fruit, right. Check if it is equal to a, increment the number of apples, else if it is equal to b, increment the number of bananas, else if it is c, mangoes, else print an error message. You could have made this condition a lot more complicated, right. You could also have said while this, in fact one of the things that you could have done could have been to say while the character that is input is either equal to a or to b or to m, run the code that is inside, right. But then what will happen is the moment I hit something which is not a, b or m, it would probably exit the loop, whereas over here I am explicitly looking for the character q. And what it will do is, after doing all of that and either printing a message or incrementing a variable, it will once again print out this enter a fruit code and do this scanf, okay. And this actually shows you one potential problem with the while loop, right. When I enter the while loop out here, I need to have the first value already in place, and the only way to get that is to actually read it, okay. There are situations where you might not be explicitly printing out an error message like this. Let us say for example that I am going to, I do not print an error message if I do not know the fruit, I just go and ask once again saying enter a fruit code, okay. Then what I could have done would have been, I initialize the character ch with something completely different, right, and let us say ch is equal to x or something like that. Then go inside and then I could basically check if ch is equal to a, b or c, do something, printf, and then go back, and now when I go back over there I would have the new value of ch to work with, okay. Yet another way is, and we will look at that, let us first run this, right. I have the same as before, I have a, b, c, m, q, and it says 1 apple, 1 banana, 1 mango, okay. It still says apples, bananas and mangoes, and this is actually an interesting place where you could use an if condition to either say 1 apple or 2 apples, right. That would be a perfect use of either the if condition or, interestingly enough, an operator that we discussed earlier, right, the ternary operator. That is the perfect kind of place where you would want to use something like this. So as you can imagine, the while loop looks a little bit complicated, right. I ended up having to first print this, scan this and so on, right. And the question that arises is there another way that I could do it? Possibly yes, right. I could maybe do this, get rid of that initial part, so this modified version of the while loop does something slightly different. In this case what it does is I have just made sure that I initialize my ch, my character, to something other than q. That is all that I care about, right. I actually do not care what the value is as long as it is not equal to q, because if I entered q I would go to this while loop, see that ch was equal to q and get out. But if it was anything, even if I had entered a, the interesting thing is as soon as I am done with this, it would go inside and read in a new value of ch. It would basically ignore whatever it got as while coming in here. it would read in a new value of ch, check the value of ch, the new value of ch, whether it's a, b or m, else print out don't know how to handle that fruit, and go back out here and now check the new value of ch against q. And as you can see, when I actually run that code, it performs exactly as I would like, right. I don't have to have two printfs, or rather another redundant version of the printf and scanf out here. This, whether this works or not, whether how you exactly go about initializing the value and how you use it in the while loop is something that you will need to sort of look at your loop, understand the behavior of the loop, and make sure that getting your inputs, getting the values, doing the computations, the order in which they can be done will still give you the correct result, right. These can be tricky at times. There can be scenarios where you end up thinking that you will be using a particular value of the input, whereas you are probably using the old value or a new value which was not exactly what you had in mind. So please keep that in mind while writing while loops in C. There is another variant of the while loop called the do while loop, right. I did not sort of explicitly bring this out as something to be considered because in most cases the do while loop is, the while loop is usually more common than do while, right. All that do while does, as you can see by sort of looking at this code, is that it reverses the order in which you do the condition check. Not reverses the order, or rather it changes the position at which you do the condition check. In other words, you perform the computation of the entire block of code and then you check whether your condition was satisfied, right. So do this entire block of code as long as this condition is satisfied, okay. So now what has happened is ch does not have a value. So what do? I run this code, I go in there and get a value for ch. It goes in, checks the value whether it is a, b or m, else prints this message out. Then it checks the value of ch whether it is equal to q or not, and if it is not equal to q, it will go back and run it again, allow you to input another fruit, right. So this works quite well, except that there is one possibly what you can call a bug in it, right. So let us look at that first. Let us look at how the program runs first, right. A, B, M, A, B, C, right. So C, it says it does not have to handle the fruit. Now is when you are going to see what could potentially be called a bug. I enter Q. It first prints out don't know how to handle that fruit, right, because it is inside the if statement out here, and then it gets out of the loop and then it prints out the done, you have so many apples, bananas and mangoes, okay. Why did that happen? Because I read in the value of ch here, I check certain conditions out here, and only after that I check the quit condition. If I did not want it to print out this last message, I should have also had one if ch equal to q, but that sort of seems redundant, right, because I am actually, if ch is equal to q, I want to get out of the loop altogether, right. So once again, all that is saying is maybe this was not particularly the best scenario in which I wanted to use a do while loop, right. The simplest way to think of a do while loop is use it when you want to ensure that that block that you are executing is guaranteed to run at least one time. The while loop, on the other hand, it is potentially possible that the condition fails as soon as you get in here, right. The very first time, if ch had initially been had somehow got an initial value of q, the very first time I hit this line of code, I will see that hey, I don't need to run any of this stuff, and it is quite possible to go through the while loop without running it even once. The do loop, on the other hand, is guaranteed to run at least once, after which it checks the condition and may or may not proceed to repeat, okay. As I said, it is not fundamentally different from the while loop, it is a relatively small variation on it. It is much less common than the while loop by itself. It is something to be aware of, right. Whether you use it or not is a different, in practice is a different story. Now, the third demo that I want to go over with while is, this is one of the places where while actually kind of shines, right. This is a scenario where I want to take an input from a user as a number, and after I have taken that input, I want to print out, let us say, all the powers of 2 that are less than that particular number. Okay. Now, the problem that I have, right, which will become more apparent when we look at for loops later, is that I do not know ahead of time how many powers of 2 might be less than a given number, right. Let us say that the number I enter is 100, then 2 power 0 up to 2 power 6 are all less than 100, but 2 power 7 is not. So, there are 7 values. If I go 1000, then 2 power 0 up to 2 power 9 are less than 1000. If I go 1100, then 2 power 0 up to 2 power 10 are less than 1100, right. So, it is not sort of trivial. There are ways, of course, as you know, there is a mathematical formula I can use, but let us assume for now that I can't really figure out ahead of time how many such values are going to be there. A more meaningful example of this would be, for example, prime numbers, right, where I do not have a formula that will tell me how many prime numbers are less than 100 or how many prime numbers are less than 1000. Okay. In such a scenario, what will happen is the while loop is perfect. What I can do is I keep changing the value of whatever it is, I, whether it is either going to the next power of 2 or that it is going to the next prime number, and I keep repeating that as long as it is less than this limit that I am interested in. So, how will that work? In this case, I will run it. If it asks me for an upper limit, I enter 100, and I can see that it starts printing out 1, 2, 4, 8, 16, 32, 64 is a power of 2 less than 100, and that is it, it stops there, right. If I run the same thing once again and enter, let us say, 1500, it goes all the way up to 1024, right, and stops. So, that while condition I less than n is just perfect, right. It exactly lets us stop when we have crossed the limit that we wanted. Notice that in this case what I am doing is I am just doubling the value of I each time that I go through the loop, right, and the moment the value of I exceeds n, my limit, it lets me rather it gets me to stop running through the loop, right. This is of course a contrived example, but you will hopefully get the idea of where this is useful, right. When the condition that you are checking for in the while loop is not predictable, right, is something that is not in general going to be known ahead of time, right. That is where the while loop really shines. You can in fact make it a much more complicated construct as well that gets checked inside the condition of the while loop, right, and there will be scenarios where you actually need to write fairly sophisticated looking conditions for while loops, right. For now we are going to stop with these examples. The next iteration construct that I want to look at, right, after the while loop is the for loop, and like I mentioned earlier, there is a reason why C and many other programming languages explicitly have this notion of a for loop, right, and it is something which is used to iterate or to run over a given block of code, usually a fixed number of times, right. The simplest example that can be shown over here is where I essentially run through, I take in as an input a number of values to add, I initialize a sum to 0, I run through the for loop and keep adding those values to the sum, which means that at the end of it, it would basically be the sum of the first n numbers, right. So what happens when I run this? I am going to say give me the sum of the first 10 numbers, right, and it gives me the number as 45. Okay. In this case, why did it give me 45? Because it thinks of the first number as 0 and not as 1, right. We can fix that if we want to. I am not going to bother, right. I am going to assume that I am starting from 0. So what I have over here is it basically starts with I equal to 0, right. You can see the notation used for the for loop. For I is equal to 0, okay. What does that mean? This part over here before the first semicolon is what is called initialization, right. Then I have I less than n followed by another semicolon, which means that it is another statement, right, and this is the condition check, which basically decides whether I am going to go through the for loop or not. And finally I have the update step, which allows me after each run through the for loop, it executes the code that I have out here. Okay. As I said, I could have taken this, put it outside the loop, kept this over here as the while as the condition, and taken this and put it at the end of the statement that is being executed, and this whole thing could have become a while loop with exactly the same behavior. Right. There is fundamentally no difference. In fact, it is quite possible that it will even generate exactly the same machine code, right, depending on the compiler, right. There are no guarantees, but there is a good chance that it will generate the same kind of machine code given the compiler. So why even bother with this? Because this is a more compact, convenient and easy to read and understand form of code. Okay. So these three steps, this initialization, condition check and update, are what more or less define the for loop. And just like in the case of ifs and whiles, everything else after it just executes the next statement. If you wanted to execute a subprogram, a block of statements, put it within curly brackets, right. So that is what we have over here, and yeah, the thing that you will notice is that I am starting from 0 and I am checking the condition I less than n, okay. So if I start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right, 9 is less than 10, but 10 is not less than 10. So it fails on the 11th step. So the value of I that I take over here is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9, right. Even though I have entered the number of values to add as 10, the value of I never actually reaches the value 10, it stops at 9. Why? Convention once again, right. There is nothing fundamentally preventing me from writing this as for I is equal to 1, I less than or equal to n, I plus plus. This would also work as a for loop, and now would actually sorry, syntax error. Yes, by the way, you might have noticed that the moment I do this, I actually get this squiggly line over here, and there's when I put my mouse over it, it shows expected expression, right. And there's a reason for that. When I leave a space between the less than and the equals, it treats it as two separate operators, and what it's saying is it expects an expression instead. So that's good, right. Once again, the editor is telling me something which allows me to prevent a bug happening later. Now if I compile this and run it, it goes ahead, asks me for the number of values to add, and now when I enter 10, it actually gives me the result saying the sum of the first 10 numbers is 55. Why? Because it started from 1 and went all the way up to 10, right. It waited until it became equal to 10. Okay. So both are perfectly valid ways of writing for loops. Having said that, conventionally we tend to do this, right, 0 and less than n. Part of the reason for that will become more clear when we look at arrays, right, because arrays, the way that we index into arrays and we access elements in arrays, this kind of notation makes more sense, or rather this numbering of the indices makes more sense. By the way, this variable I in this context is called an index variable, right. It is the index that determines how many times we have run through the loop. Okay. And what we can see over here is that I start out with 0, I first check is 0 less than 10, I check that immediately, it is just like a while loop. Okay. So, if I start out with 11 for example over here, right, or even 10, right, and I run this, what I will find is that it actually prints out that the sum of the first 10 numbers is 0. It seems to have gone out of this without adding anything, right. So, clearly that is not what we want. So, instead I am going to leave it like this, at which point it will give me the value that I want. Okay. So, you will see that it first runs through 0, then 1, right, and then it goes through, finally increments to 1, runs through this sum, then checks the condition, 1 is still less than 10, okay, increment to 2, then go increment to 3, increment to 4 and so on. Finally, it hits 10, it immediately checks is 10 less than 10, no, and stops, it does not execute the code after that. Okay. So, the order in which these steps happen is something that you should probably play around with and make sure that you understand them exactly, right. There is an initialization which happens the very first time, it happens only once before the for loop starts. The condition check happens immediately after the initialization. So, if you have failed the condition check right away, it is possible that the for loop exits without even running once. The post increment happens at the end of the iteration that you have just conducted, right. So, you finish going through the entire thing, increment, go back and check the condition, right, which means that after you have run the appropriate number of times, on the next step you will fail the condition and you will immediately get out without running through the body of the loop again. Okay. So, this is the basic nature of a for loop. This is sort of the simplest and probably the most common form in which you will end up using it. There is just one small additional thing that I want to point out over here, unrelated to for loops, but related to numbers in C. Let us run this through and see what we can do. Let us, can this add large values, right, sum of all the values from 0 up to 12,344, and literally, I mean, it's, by the time I have pressed enter, the answer is available out there. Now, let us see another interesting thing. What happens if I go even bigger than that, right, all the way up to 12 million, right? The answer according to C is that when I start adding enough positive numbers, I suddenly end up with a negative number. Okay. Why is this happening? Please think about it. It is all related to 2's complement and the fact that there is what is called overflow, right. When I add enough numbers, I go beyond the range of what can be represented using a 32-bit integer. The most significant bit of those 32 bits gets set to 1 at some point. As far as the program is concerned, it therefore starts treating it as a negative number, right. So, there is overflow. When I overflow beyond the range of what can be represented in normal positive numbers in C, it just treats it as a negative number and moves on. It does not complain, it does not tell you that there is any problem out here. This is something that you need to watch out for because it can be problematic in many scenarios, right. The computer, in other words, is not going to catch these kind of errors and explicitly tell you that something went wrong, it went beyond the range of what I can compute. If you want to do that, you will have to modify your code so that there are additional if conditions in various places that check whether you are going out of bounds, right, beyond the range of what you can compute, and if so, handle it appropriately. So, the next demo with the for loop is just to demonstrate something called multi-declaration, right, where we are essentially going to make use of the comma operator that we talked about earlier. And what I have over here is the initialization part of the for loop. I am simply going to put in two variables that are being initialized, right, for I equals 0, comma j equals 1. Okay. Both I and j have been declared as integers ahead of time. So, I can do this kind of initialization where both of them are being declared at one shot, or rather being initialized at one shot using a single statement, right. Keep in mind that this could not have been a semicolon. If I had put a semicolon over here, it would have made it the next part of the statement, which means that it would have made it, or rather it would have made it the next statement, which means that the j equal to 1 would suddenly have been the condition check that I need to do, right. But by making it a comma, what happens is that both I and j have got initialized. The condition that I am going to check is j less than n. I am not even checking the value of I, okay. And what I am going to do is internally I will increment I, but j will get multiplied by 2, okay. And what I do is print 2 to the power something is something, right, so that I have I and j out here, right. If you look carefully at this, what is it doing? J is getting doubled each time, which means it is computing the powers of 2. I is just getting incremented, so it is keeping track of which power, is it 2 power 0, 2 power 1, 2 power 2 and so on, okay. And if I run this, sure enough what I will find is upper limit, let me put 1000, and it says 2 to the power of 0 is 1, etc., all the way up to 2 to the power of 9 is 512, right. You can imagine that this is a much more compact version in some sense, or maybe not a more compact version, but at least equally compact or possibly even more compact than what could have been done with the while loop. In particular, in the while loop, I would have had to add a little bit extra if I wanted to print out which power of 2 was being printed, right. I was not keeping track of that in the while loop. Whereas over here I am able to do all of that pretty much using one invocation of the for loop, okay. Once again, my recommendation is, although this looks nice, it is very hard to understand, okay. It is not particularly helpful from the point of view of any kind of optimization. It is not as if it results in better optimized code or something that will run faster on the computer. The only thing that it really achieves is that it makes it harder for somebody else to understand later, right. So, although this can be done, it is probably something to be avoided unless absolutely necessary, or unless there is some compelling reason which makes it elegant and a nice way of writing your code. So, the third demonstration that I am going to show with the for loop is using the for loop to emulate a while loop. Needless to say, hopefully if you have been following along with the rest of this video, it should be clear by now that this is something I do not like, right, and hopefully I will be able to convince you with the code that do not do this, right. Like I said, there is nothing fundamentally wrong with it, there is nothing syntactically wrong with it, the language allows it, but it is still bad news, it just makes it hard to understand. And this is using the original version of the while loop, right. I put the scanf out here. What I have done is I have essentially written a for loop out here, right, where I do not have an initialization block, I do not have an update block, I just have semicolon and semicolon, right. Now, what exactly does it mean, just a semicolon without anything before it? Nothing, that is what is called an empty statement in C, which is a valid statement. An empty statement is a valid statement, right, which is why even having something like semicolon, semicolon, semicolon is perfectly valid in C, right. Just having like 2 or 3 semicolons one after the other is not syntactically wrong, right. It does not add anything to the program, it is not clear why it is there in the first place. So, it is probably something to be avoided, but it is not wrong, it is not forbidden by the language, right. And for the same reason, this for loop written this way is effectively a while loop, right. All that happens is somebody looking at it gets confused and thinks that isn't this supposed to be a while loop, or what exactly is happening out here, right, and it probably takes a little while to understand what is going on. Behaviorally, it is exactly the same as the while loops that we already discussed. So, you can of course try out the code and see what happens when you run it, but it is not really going to make any difference to the final output. As I already said, code of this sort is permitted by the language, it is preferable to avoid it, right. There could be scenarios where something like this once again is an elegant way of representing some particular condition, but you are probably going to find that just using a while loop instead was equally good. So, I can't really think of a good example where this is the best way of writing code. Keep that in mind. If you do come across it, you should be able to interpret it and understand what it means, but it is preferable not to use it when you are writing your own code. So, now that we have completed the different kinds of iteration constructs, let us take a step back and look at what I mentioned as the generalized if-else condition, right. We already saw in the fruit counter example that we had this if else kind of construct, right, where I would first check if the character was equal to A, else it's equal to B, else it's equal to M, and so on, right. Is there a cleaner or nicer way of representing the same thing, right, is something that we can ask. And it turns out that because this is a sufficiently common kind of occurrence, right, there are many scenarios where I want to sort of check the same condition again and again. C actually provides a construct for writing that code compactly, right. And the way that we would write it would be something like this. The while loop remains exactly the same as what we had with the if conditions. All that I have done is I have this new keyword called switch, and what I am saying is that I am going to switch my operation of whatever follows out here based on some condition, or rather based on a particular variable, right. So, I switch based on a variable out here, and what I do is I check different cases. I say if, in other words, this case A is exactly the same as saying if ch is equal to A. What should I do? I should do apples plus plus and note this next statement, right, break. This turns out to be very important. What it's saying is, okay, ch was equal to A, very good, do this code and then break out of this loop, which means get out of the switch, go all the way down to line number 254, right, that is to say till the end of the switch case. Okay, the switch case by itself goes all the way from line 241 out here to 253. The curly brackets show you where it starts and where it ends. The break tells me stop any further execution and go to the end of that piece of code, which is line 253, or rather just after line 253. Okay. Case B, increment bananas, break. Case M, increment mangoes, break, right. And the default where I have not entered any of these is print don't know how to handle that fruit. In some ways this is even cleaner than the if else, right. I don't have a lot of extra curly brackets and verbiage and so on. I do have a bunch of these breaks out here which we will have to look at, why do we need these. But apart from that, I clearly have this thing saying default, that is it's not matching any of the cases, what should I do, and I can have maybe fairly complex bit of code out here as well. What happens when I run this, right, sure enough it works more or less as expected, right. 1 apple, 1 banana, 1 apples, 1 bananas and 3 mangoes, right, all exactly what we expected to see. So, the switch case statement is precisely that, it is going to be a shortcut or a replacement for nested if else conditions. Okay. It is not exactly a one-to-one mapping. There can be scenarios where switch case is very compact and if else would have been difficult to write, but there can be scenarios where you can express something using nested if else's which are not easy or maybe not even possible to do using switch case, right. The if else is the more general form of the selection statement, right. So, in general you should be able to do everything using if else. Under certain circumstances the switch case can make the code that you write a bit more compact and easy to understand, right. Once again it's the same story. These are constructs that are put in there to make the particular thing that you are writing a little bit easier to understand because it's now grouped together as one logical construct. You are looking at one particular value and based on the different things that can happen, you perform certain operations. Now, the switch case statement on the other hand unfortunately also has the one pitfall that you need to be aware of, which can easily lead to bugs if you are not aware of it, right. And that relates to the presence of those break statements that we saw earlier, right. And as you can see, what I have over here is exactly the same code with the only difference being that I have removed all those break statements. And let us run it to see what happens as a result and then sort of understand why, right. I am going to enter 1 apple, okay. In fact, this is interesting. Hopefully you have already figured out why that happened. But let me so now I have entered 2 apples, 1 banana, 1 mango, and you will see that in each case it ended up printing the message, don't know how to handle that fruit. Okay, we need to understand why, but before that let us look at the result, what happened out here. So according to this I have actually entered 2 apples, 1 banana and 1 mango, but the program seems to think that I have entered 2 apples, 3 bananas and 4 mangoes. What happened? The answer is the missing breaks, right? And what has actually happened in this case is it came through the switch statement, it found the condition A. The first time around it found that the condition A was satisfied, yes, very good. It incremented the value of apples. It basically did not even look at this case B, right? But it did look at the next statement, bananas plus plus, and thought, okay, this is something I need to execute, right? It did not look at case M, decided that mangoes plus plus is part of my code, I need to execute this. Skipped over the default because none of those are the matching conditions. Printed the output, don't know how to handle that fruit even though it was an apple. Went back once again, looked for it, right. So the first apple basically has already incremented apples, bananas and mangoes. The second apple did the same. So by the time I have run through it twice, I have got apples equals 2, bananas equals 2, mangoes equals 2. But the next time I entered B, right, and when I entered B, what happens is it goes through the switch, it sees whether CH is equal to case A, and that is not the case. It actually skips the next statement and comes through and checks for case B. Yes, that is in fact satisfied, so it does bananas plus plus, but then it goes on and does mangoes plus plus. So now apples is 2, bananas is 3, mangoes is 4, and it still prints out, don't know how to handle that fruit. The third time and the fourth time around I entered M for mango. What does it do? It sees case A, not satisfied, it skips this line, apples plus plus. Case B, not satisfied, it skips bananas plus plus. It sees M and it does mangoes plus plus, so that mangoes is now equal to 4, bananas is 3 and apples is 2. Prints out, don't know how to handle that fruit, and finally when I enter Q, of course the while loop gets it out and it prints out this message saying you have 2 apples, 3 bananas and 4 mangoes, after having printed all those, don't know how to handle that fruit, right. There is nothing more to say about this except for the fact that it is a potential bug, right, in any switch case statement that you write. Why was this particular behavior chosen in C? It was related to the way, and it's probably related to the way that branching is implemented, or how this code translates into machine code. But if you really think about it from the pure point of view of understandability, it is not easy to justify why something like this should be done, right. There are scenarios where people have actually made use of this in order to actually write very clever and elegant code for handling certain kinds of choices, right. But in general, code of that sort turns out to be complex and more complex than it is really worth the effort of, right. It can easily lead to things that are difficult to understand.